Okay, so we have our next question, which says, how do we convert between polar and rectangular coordinates? So we do have a moderately easy way to convert between them. But first, let's explain what is the difference between polar and rectangular coordinates. So rectangular coordinates, we are normally pretty familiar with them, like our xy. I'll draw out something like that to just show it. So check out this. This would be like the y-axis. Perpendicular to that, we'll have our x-axis. And let's say we have a point A here, and it's at position like x of A, y of A. We would see like it would intersect with the y axis at y of A, and it intersects with the x axis at x of A. Fairly straightforward stuff that we are most likely already familiar with. Now, polar coordinates are a little bit different. So we can draw out our same axes here, but we don't necessarily want to label them x and y. Let's say we have point A here. You want, instead of x and y coordinates, we have our points defined by an r value and a theta value. The r value corresponds to the radial distance. And the theta value corresponds to angle. And you do need to define our like zero angle point. So let's say this horizontal axis here is going to be our zero angle. So you see how A is defined like, okay, first we go, a certain direction amount along the x-axis. We'll call that xa. And then we got to go up in the y direction by a certain value y, A, to find our point A. Here we're going to do something similar, except first we're going to find our angle. So just to show this like visually, this distance here, that's r. That's the radial distance away from the origin. So I'll just draw that out. Origin, like where we originate from. That's a nice way to remember that. So we have our r, our distance away from our origin. And then we have the angle that it makes, which is theta. Okay, so the secret sauce to the conversion between rectangular and polar is, first we got to know that it is always possible to convert between polar coordinates and rectangular coordinates. We just need to find the conversion. Now you see how, just looking at this, it does have a triangular-like shape. Let's say that this is A. How would we find the coordinates of A? Well, if we look at the r, this is basically the hypotenuse of a right angle triangle with like its two short ends, like the adjacent and opposite sides, not the hypotenuse. Basically the perpendicular parts of this triangle are the x component and the y component. So to find the length of r, which is just the hypotenuse, we're basically going to do Pythagoras Theorem. So we know that r is the hypotenuse, right? And Pythagoras Theorem says that the hypotenuse squared is equal to the perpendicular parts of the triangle squared and added together. So this would be like x squared plus y squared. Let's isolate for r on its own. So without the r squared part, we can just make that r is equal to the square root of x squared plus y squared. Cool. Now, should we worry about plus minus? Yes. In general, you should assume that your r is positive. Sometimes if you'll get it negative, some questions will ask for that. If for example, we have like theta has the angle this way. If r happens to be negative, that just means that we're going in the opposite direction. Okay, so the angle would be the same. It's just like instead of a being here, it would be around where origin is written. But in general, like you want to be able to look at your graph and specify like r. In general, you want r positive, and then you specify which quadrant it is in with theta. But some people do it either way, so stay ready for both. Okay, so we found r. Nice. How do we find our theta? Our theta value is the angle that our r makes with like our 0 degree axis. How do we find that? Well, in a similar way to how we found r based on the knowledge that this is very similar to a right angle triangle, we can also find theta knowing that this is extremely similar to a right angle triangle. So let's say we have a triangle like this. I guess we did find r, and this is our y, and this is our x. That's our theta. We could use theta to calculate it, but I mean, we could use r to calculate theta, but I feel like it'd be more direct if we're trying to go from polar to rectangular to use x and y. So we know with our lovely trigonometry knowledge that the tangent of theta is equal to the rise, the y, divided by x. So let's say we want to isolate theta. We'll just take the inverse tan of both sides, and that will cancel out the theta on the left side, and we'll have the arctan or inverse tangent on the left side, and that will give us our angle. So theta is equal to arctan or inverse tan. Different names, same thing, but you know, be ready for both, of y divided by x. That is super cool. So now we have our r like that, and we have our theta like this. So this would be how we go from, like if we're given x and y and we're starting in rectangular and we're going to polar, well, we just take our x and y values, stick them in this equation to get the r, stick them in this equation to get the theta, and then we're good. If we are given our polar coordinates, like if we're giving an r and a theta and we have to find its rectangular equivalent, we would just do the same process in reverse. So you would like do regular tan to both sides, and then you would have a ratio for x and y. And then here, like you would square both sides, and you could solve for x and y individually. It's fairly simple. How about we run through an example? Let's say we want to convert the point 3. So like this is x, and 4, and this is y. So this is rectangular. Rectangule. Okay, and let's convert it to polar. So we know our polar equivalent is going to be like r theta. We know that r is equal to this. So we have our x squared plus y squared, all under the root. And our theta is inverse tan, also known as arctan, of y divide x. Okay, let's sub in our numbers. We have 3 for x. So we have 3 squared plus y is equal to 4. 4 squared. Okay, and our inverse tan is 4 divided by 3. Okay, so 3 squared, that's 9. 4 squared, 16. 9 plus 16, 25. Square root of 25, that's 5. So we're going to have an r value of 5. And what's the tangent value going to be? Well, mental math of inverse tangents is a little more difficult. So I'm going to pull out my handy dandy calculator, and I'm going to do the quick calculation of inverse tan of 4 divided by 3. It's about 53 degrees. 53.13 degrees. Sometimes you'll need to do this in radians. It really depends on what type of applications you're using this math for, but be ready for degrees and radians. Of course, like converting to radians from degrees is not particularly difficult, but just know that you really got to be ready for both. So a 53 degree angle would look something like this. And this distance would be 5. Now, does this make sense? Does this line up with a point 3, 4? Like we would go 3 along the x direction and then 4 upwards? Yeah, it does make sense. So to convert between polar and rectangular, use these very special equations. The radial distance, x squared plus y squared. Put them under the root. That will give you the radial distance. Beautiful. And then for the angle that it makes, just take the inverse tan, also known as the arctan, of the y component divided by the x component. Super cool. And this will be very useful for some pretty advanced math stuff, but you know, it's good stuff to know. I guess another thing to add that I guess we see here in this is to go the other direction. Let's say you're given let's say that you're given the polars and you want to go to the rectangular. Well, we have special equations that help us do that. So we know we have like x is equal to r multiplied by cos theta. And we have y is equal to r multiplied by sine theta. Now, why does this work? Well, let's say we have a situation like this. This got a length of r. It's got an angle theta. Like this right here would be its x component. This is really just why it is cos is like cos is the relationship between the hypotenuse and the side that is adjacent to the angle. You multiply the hypotenuse with the value that cos gives you for the angle, and it'll give you the x. Makes perfect sense. And the similar thing for the y. Sine is the ratio between the hypotenuse and the opposite. You see opposite, it's on the other side of the angle. And that's just like the ratio between them. We multiply them by the actual value of the hypotenuse, and we will calculate y. So these are also key equations if we want to go between polar and rectangular. These two equations, as well as these two equations. And it would seem like the answer or the solution that is given on OneNote is already or agrees with us. So we can say that the above solution is correct. Good stuff. So that would conclude this question.